Hello everyone. On this video we will be going over the derivative of natural log functions. Alright, so to get started, we'll show that the derivative with respect to x of natural log of x is 1 over x, and the derivative of the natural log of a function of x is equal to 1 over that function of x times the derivative of that function of x, or the derivative of the natural log of a function of x is equal to the derivative of that function over that function. Kind of clean that up a little bit. There. Alright, so first thing we're going to do is go ahead and prove these. They're pretty quick proofs. So we'll say this is the first one and this is the second one. So proof of the first one. Okay, so what if we let y equals natural log of x? Okay, so what if we go ahead and after that and raise both of those to e? Okay, so e to the power of y equals e to the natural log of x. Okay, so we know that the e and the natural log kind of cancel each other out. So we have e to the power of y equals x. Okay, so we're going to go ahead and differentiate both sides. So you have the derivative of e to the power of y equals the derivative of x. Okay, so we kind of manipulated our initial portion, but this is where it got us so far. Okay, so if we take the derivative, again, using the chain rule, we have e to the power of y times the derivative of our exponent, so derivative of y with respect to x equals the derivative of x is just 1. Okay, so if we go ahead and divide both sides by e to the power of y, that will give us our dy dx is equal to 1 over e to the power of y. Okay, but our y is equal to natural log of x. So our dy dx now equals 1 over e to the natural log of x. Okay, but we know that the e and the natural log cancels each other out, so it just leaves the x. So it's going to be 1 over x. Okay, so that's the proof of the first one. Now let's go ahead and prove the second one, which kind of piggybacks off the first one. Okay, so we have proof of the second one. Okay, now to prove the second one, we know that dy dx is equal to 1 over x for our natural log of y, for y equals natural log of x. Okay, so that's going to come in handy. Okay, so if we apply the chain rule, if we have y equals the natural log of a function of x, we can let our u equal g of x. And if we take the derivative of u with respect to x, that's just going to be your g prime of x. Just another way of saying your derivative. Alright, so if you remember the chain rule, derivative of y with respect to x can equal the derivative of y with respect to u times the derivative of u with respect to x. Okay. So remember, we had our g of x equal u. So let me kind of make a little side note. So it means that y is equal to natural log of u. So the derivative of y with respect to u, remember that natural log of x is 1 over x. So natural log of u derivative will be 1 over u. So that would equal 1 over u times your du dx. Remember, that's g prime of x. Or you can just leave it as du dx, really, for right now. Okay, so if we go back and replace our u with g of x, then that means our dy dx, move that up a little bit, is equal to 1 over g of x times du dx is your g prime of x. Or you can make it g prime of x over g of x. Right, so they're pretty straightforward proofs. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and jump to some examples. Alright, so let's say for our first example, if we wanted to find f prime of x for f of x is equal to natural log of 3x to the third power plus 4x squared plus x plus 4. Okay. Now to do that one, you just have to remember a couple of things. Okay. You have to remember that your derivative of the natural log of an entire function is equal to g prime of x over g of x. Okay. Now what else do you have to remember? Well, you also have to remember your basic rule for logarithms. So you have your logarithm rules, which also work for your natural logarithms. Okay, so if you have your natural log of m times n, remember that's natural log of m plus natural log of n. Remember, that's the product rule for logarithms. So that's the product rule for logarithms, even natural logarithms. Okay, and you also have the natural log of, let's say, m over n will equal natural log of m minus the natural log of n. That's your quotient rule for logarithms. Oh, forgot my little s there. There we go. And last but not least, you have the natural log of m. Let me clean that up a little bit. M to the power of p, which will equal p natural log of m. And that's your power rule for logarithms. So your power rule for logarithms. Alright, so those will help if you start on your natural log derivatives. Alright, so we're going to go ahead and solve this one. Well, I should have put the solve down there since we're actually starting to solve it down here. These were kind of don't forget about us things. All right. So what if we let me rewrite it, f of x equals natural log of 3x to the third plus 4x squared plus x plus 4. So that means the derivative is going to equal, because remember, this is your g of x. Okay? So put this as like a little side note. So if g of x is equal to 3x to the third plus 4x squared plus x plus 4, then g prime of x is going to equal 9x squared plus 8x plus 1. Okay, so remember, your derivative here is going to equal, let me make that g prime of x over g of x. Alright, so that means it's going to equal 9x squared plus 8x plus 1 over your g of x, which is 3x to the third plus 4x squared plus x plus 4. Alright, so for this one, you didn't need the rules. I don't know why I put these here instead of in a separate page for their own, but you don't need the rules here, but you will need them for the next example. Alright, so if you are still writing, feel free to press pause, but remember, you will need them for these for the next example, so if you want to, you can kind of keep this visible. Alright, so let's go ahead and move on to our next example. Alright, so let's say, for example, you want to find the derivative of f of x equals natural log 3x plus 2 to the fifth power. Alright, now the reason you will need those rules for logarithms will be because for your f of x equals natural log of 3x plus 2 to the fifth power, using the power rule, for logarithms, f of x will equal, remember, you have that 5 is going to come down. So that's going to be 5 times natural log of 3x plus 2. Okay, so it's really just a comeback of your old logarithm rules from pre-calc and intermediate algebra that's kind of showing their head again. Alright, so now to find our derivative, that's going to be 5 times the derivative of natural log of 3x plus 2. Okay. Now in this case, we know that this is your g of x. Okay. So g of x is equal to 3x plus 2. Then that means your derivative, g prime of x, is going to just equal 3. So that means this will now equal 5. Remember, the derivative of a natural log function is g prime of x over g of x, which is 5 times 3 over 3x plus 2. So you have 5 times 3 would give you 15 over 3x plus 2 as your derivative. Alright. So, hopefully this made sense, and I will see you on the next video.